Today I want to take some time to talk about the latest design tool from Toolmatic, the Drive Integration Tool, or for short, DIT. Toolmatic is focused on developing tools to help design engineers optimize their mechanical designs and be as efficient as possible. We have now leveraged our experience in tool development to simplify the process of selecting and commissioning drives for use with servo linear actuators. Servo linear actuators are one of the fastest growing segments in automation. Their simplicity, compact design, and sheer power make them the preferred choice for linear motion for a wide variety of applications. However, what seems intuitively a simple solution can be challenging if you don't have the right tools to ensure compatibility with your control architecture. Drive manufacturers typically optimize their selection tools to easily match a motor from the same manufacturer. However, when you have made a decision to optimize your mechanical design with a servo linear actuator, navigating the available drives, appropriate feedback options, and cables can be overwhelming with a third-party motor. But it doesn't have to be. With the Drive Integration tool, you can simplify that process and make that efficiency translate as well into the commissioning and integration side of a project. So, Toolmatic design tools are located in toolmatic.com on the main page towards the middle of the screen. The Drive Integration tool will be located next to the wide array of tools that Toolmatic offers as well. To access the tool, you can just click on the logo shown on the website, and you don't need an additional login or an account to access this tool. This is available for anyone in our website. On the top, you can see some drive integration resources, additional documents, frequently asked questions, and also the access to the Drive Integration tool. Depending on the specific scenario or project that you're working, you can follow two different paths. You can start with your servo drive, or you could start with your servo actuator. Both will reach the results, but when you use one or the other might depend on the specific situation you're working on. For example, if you or your customer has a specific servo drive manufacturer they're more comfortable with or they use on a daily basis, you may start by checking out which servo drives might be compatible with certain actuators or feedback codes. So by clicking on servo drive, I have now selected my starter point on the application, and I can click next. On the second step, now I get to select my drive manufacturer from this drop-down list. For this example, I'm going to use Rockwell Automation. After the drive manufacturer is selected, the drive series menu will be populated with the specific drives for that drive manufacturer that are in the Drive Integration tool database. In this example, I'm going to go with a Rockwell Kinetics 5500. After making that selection, I can click Next, which will bring me now to the servo actuator menu. In this menu, I'm going to be able to select an IMA or IMAS or the specific servo actuator model that I'm going to be working with. So for this example, I'm going to go with an IMA 33. Then I'm going to select the motor specific to that configuration that I'm working on for the integrated servo actuator that I have selected for the project. For this example, I'm going to go with the MV23, which is a 230 volt 3-stack motor. For more information on what each code means, you can select the information button to the right, which will display a summary of what our annotations and codes mean in terms of performance and specifications for a specific configuration. Similarly, if I select the feedback code menu, I'm going to be able to select the already filtered codes for that specific configuration I had previously selected. The codes shown here are compatible with the specific manufacturer and the specific drive model that I had selected in the previous step. So in this case, I'm going to go with DA1A1, which corresponds to Rockwell connectors and to the hyperphase feedback device. So you can click that. And again, if you need more information on what each of those codes mean, you can click on the information button to the right and it will display a summary of how to read those codes and what each digit means. Lastly, I'm going to have the option to select whether or not the configuration I'm working on has a brake. In this case, I'm going to select the brake option and I'm going to click Next. Which brings us to our last page. It's a results summary page where you will see on the top left side your configuration selection. You're going to see the specific manufacturer along with the drive model that was selected. On the right side, you'll also see the motor data, which is going to be displayed and tailored towards the specific information you will need for the manufacturer selected in order to interface and to enter this information into the drive software and correctly integrate this specific model that you're working on. Similarly, you will also have feedback data that will be displayed for the specific configuration that was selected and for the specific manufacturer selected as well. If we scroll down, we will also see the pinout diagrams and the pinout list for the power connector, the feedback connector, and in some cases, you will just see one in case it's a single cable option. One of the most powerful results that this tool will provide the user will be suggested power and suggested feedback cables for the specific drive manufacturer, drive model, and configuration for the integrated actuator that was selected. With this base part number, the user will be able to source the correct recommended or suggested cable for this specific case. There are some portions of the base part number that will be placeholders, as we call them, denoted by X's on the part number. Those placeholders relate to or denote that a specific digit might be an application-related selection for which we leave it open for the user to select the appropriate option for the specific application. In addition to that, the user can also print the results to a PDF, which will download the PDF file that can be opened in any PDF program reader, and the PDF will also denote the same information printed on the summary page. This way, this can be shared across email or any other platform for an easy document to reference when integrating a Toolmatic product. Similarly, we can also do the same in an Excel format. We can just click on the Excel button, download the file, and it will display the same information that was shown previously, but now in an Excel format to share across different platforms. The tool has also the ability to reset the selections and now take a different path, a different approach. The tool also offers an alternative path for a different type of situation. A good example would be when the actuator was already sourced and it's ready for installation and commissioning. In that scenario, the controls engineer working on the specific project will already have the servo actuator model and the servo drive model available to do the integration. In that case, then we can start by the servo actuator on this selection tool. We will see a similar menu. The order will be the thing that changes, and we can select the same IMA or the same integrated actuator that we did before. So we're going to go with the IMA 33, MB23, and we're going to select now the same Rockwell code. As you can notice now, the codes that we display or the list that we display is a larger list with different codes, different manufacturers. This is because at this point we know the actuator that we're going to select, but there's several different codes that are available for that actuator, so we're not yet filtering since we don't know which servo drive model we need to use. In this case, we're going to follow the same example as before. I'm going to go with the DA1A1 for Rockwell and for Hyperface as a feedback device. I'm going to select the brake and I'm going to click Next. Since now we selected already a specific feedback code, we see that the manufacturer was automatically selected. This is because we selected a Rockwell specific feedback code, so we do not get any other options for the manufacturer. However, we do get to select a specific drive series. In this case, the drive series drop-down is already filtered based on the previous selection for our feedback device. So this drive series or this drive models will already be compatible with that specific code that was selected. I'm going to go with the 5500 in this case, and I'm going to click Next. This brings us back to the same results page, showing our specific model, showing our specific manufacturer and drive model selected, along with the suggested power feedback cables, pinout models, and pinout tables. Similarly to before, you also get the motor data displayed with the motor information that you will need to interface with that specific motor drive controller. So you can click Close, and same for the feedback data. This is a good way to summarize the information that a controls engineer or an engineer working on a specific commissioning project might need when initializing that first interface. Once you reach the results page, the program has reached its end. As mentioned, it will display the information necessary to make the drive integration with Toolmatic integrated actuators as easy as possible. However, if any questions come up, you can always go back to the Toolmatic main page and use one of our design tools or design contact points with Ask an Engineer. With this tool, you'll be able to contact the Toolmatic engineer directly to get support on any questions related to the drive integration tool, integration methods, or Toolmatic products in general.